this section is going to talk about measures of variability, which really just means how spread out our data values are. So let me just start right there. It doesn't make any sense to talk about how far apart our data values are if I can't actually find a distance, right? So they've got to be numbers. I've got to be able to basically subtract the two numbers to figure out how far apart they are. This makes no sense for categorical data. So any types of measures of spread are going to be measuring how far apart numerical data values are. So that's just a simple way of getting started with this, of just understanding what this spread really means. Let's think about what might have more variability, the incomes of college students or the incomes at a Microsoft corporate office. Okay, let's think about that for a moment. So college students in general are not billionaires or multi-millionaires in general, right? There's a reason that college students are commonly associated with ramen and frozen food, right? Like this, these are generally speaking, college students tend to be on the lower spectrum of incomes, right? Especially while they're in school, because they're spending most of their time studying, not working, right? So as far as what we might see, we're going to see definitely some variability. I don't mean that as like literally everybody, but the great majority are going to be in this smaller group, and there's not probably going to be any billionaires here in my Math 1000 course at Casper College. So let's compare that to the Microsoft corporate office. Okay, so there's going to be anywhere between custodial staff and, right, like temps and other like office workers to literally like CEOs and CFOs and all this stuff that are making, you know, millions of dollars a year versus hourly employees making closer to minimum, right? So there's going to be a huge amount of spread in those incomes, especially when you compare it to Casper College student incomes, where they're mostly going to be tightly packed together around lower income levels, right? So that's what I mean by spread. We would absolutely see way more spread in that data when we're looking at the Microsoft corporate office. So that's what we're really looking at here. These ideas of variability are commonly used all over statistics, but especially so when we look at kind of quality control issues, right? Like if my phone case is on average exactly the right size, but it has so much variability that sometimes it's like 1/8 of an inch too small and sometimes 1/8 of an inch too big, but it averages out perfect. Like, who cares, right? It doesn't fit my phone, right? So this idea of where things are on average isn't always really the point. We need to actually consider variability as well, right? Definitely with like your pharmaceuticals that you're getting, right? If your pills say 100 milligrams of the drug on it, it better not have somewhere between 0 and 200, but it averages out to be 100, right? That's completely unreasonable. So we're going to really care about this idea of variability. And for those of you in business or economics or something like that, this also is really just volatility, right? How much these prices are moving, right? Where if we want a safe investment, we don't want prices all over the place. But if we're willing to take some risk, then allowing a lot of movement is going to be fine, right? And that movement in price really is how much spread there is. So anyway, those are just some real life examples that we might see with variability. And the very first measure, and we're only going to be looking at 2 of them really in this course, is going to be the range. Okay, so this is very easy to calculate. It's literally just the maximum value minus the minimum value. So notice this is only one number, right? So in plain English, if someone asks me for the range of student ages that I have in my course, right, in plain English, I'd be like, oh, my students are typically like 18 years old to 30, right? That's most of my students are in that range. That's not what we mean in statistics. Statistics, it's one number. I don't say 18 to 30. I would do 30 minus 18 and I'd get 12. Okay, and it would just, that 12 is how far apart those minimum and maximum values are. So just be aware of that, that this is not the same as what we mean in plain English when I ask you what the range is of, student ages, or what the range of incomes is, right? Range of incomes, like if you were asked that outside of a math or stats class, they would probably be asking, right, what's the minimum to the maximum, right? And here we're just subtracting those to get the one number. As we talked about when we were looking at outliers earlier, if I have an outlier, by definition, it's going to be a minimum or a maximum, right? It can't lie far away from my other values and not be either way below, in which case it's the minimum, or way above, in which case it's the maximum, right? So by definition, those outliers are going to be a minimum or maximum. So that makes this particular measure very sensitive to outliers, right? So, right, like my typical classroom is actually usually 18 to 30-year-olds, but every once in a while I'll get somebody that's like 60 or 70 years old that's just coming in to learn something they just never learned about before, and that's fine. But that outlier is going to, right, if I take the 70-year-old, subtract off the 18-year-old, it's 52 years now, right? It makes it seem like there's a huge amount of variability when actually most of the students are still 18 to 30, and I've just got that one outlier. That's fine, right? And sometimes we actually care about that a lot. And again, it kind of quality control kind of issues. Maybe you want something sensitive to immediately detect when, your product has gone off the rails and you need to work on that quality control a little bit more. That's fine, but we just need to know that this is very sensitive to outliers so that we can apply it to the right situations. All right. So before moving on from this, because that's really all I need to talk about with the range, it's very simple. We just subtract these two things and just know that it's sensitive to outliers. But outside of that, we don't really need to do a lot of examples with that. It's just subtracting two numbers. But let's look at these two different data sets. Okay, so I want to find the mean, median, and range for the following sets of quiz scores. I suggest you pause the video right here and actually just find those real quick. Okay, so now that I'm sure all of you have paused it and done this, let's compare notes here, right? So the mean for both is 5. The median for both is 5. The range for both is 10. So mean, median, and range are exactly the same for both of these situations, right? And these are quiz scores like out of 10 points, okay? Let's just picture it that way. All right, well, in the first one, just about everybody got a 5 with one perfect and one 0, okay? But just about everybody got 5. In the second one, there were only the extremes. You either got perfect or you got nothing. These are completely different situations, okay? And if I were to just quickly picture what a histogram would look like, right? For the first one, right, I had one person that got 0, then a bunch of people that got 5, and then one person that got a 10. Okay, one little outside the screen, but you get the point here. This is supposed to be drawing a bell curve. Hopefully all of you saw that. So this is symmetric, bell-shaped. Okay, what about the other one? Well, we either got 0s or 10s. So I got this, and I got this. These are completely different. And my point as I go through this is this whole section is talking about measures that we might use to understand the data. All of it's going to break it down into one number, or if we're looking at a measure of center and a measure of spread, maybe two numbers, right? But none of it's going to get this idea across. And so whenever people come to me and ask me, well, what's going to be the best measure to describe this data? I almost always come back to, well, can we just make a picture? It's a lot more informative. So, again, as we're going through these, I would argue that most of the time a picture is going to be much more enlightening than any of these particular measures, because we can have situations like this where we've got wildly different data that ends up giving measures that are exactly the same, right? So just be mindful of that as you go picking an appropriate measure for your data, is that pictures tend to be better anyway.